Find all complex zeros of the polynomial function and then give exact values and list multiple zeros as necessary. So here is our function. Okay, so here's our function, and the first thing we need to do is determine, okay, what are all the possible rational zeros of this function? So we have p, and then we're dividing that by q. Okay, now p represents the constant. So in the numerator we have plus or minus 135. In the denominator we have plus or minus 1, which represents q. Okay, so what we want to do is find all factors of 135. Well, we know that plus or minus 1 over 1 is a factor. The next one is 3. Is 2 a factor? So we can go ahead and do that on the calculator. So let's go ahead and do that. So we have 135, we know divided by 2 doesn't give us that, right? So we know 1 and 135, we know that 135 divided by 3, that's 45. So we know that plus or minus 3 is a factor, right? 4 is not divisible by that, but 5 is. So 135 divided by 5 is 27. So we know that plus or minus 5 is a factor, or a rational zero, not a factor, excuse me, a possible rational zero. 135 divided by 6 doesn't work. 135 divided by 7, not factorable. 135 divided by, let's see here, any other numbers there, is 135 divided by, let's say, okay, so we saw the other values. So we have 135 divided by 3, so we have 45. Right, so 135 divided by 9. 135 divided by 9, and that's 15. So we know we have plus or minus 9. We have plus or minus 15. And then we know that 5 times 45, 135 divided by 5 was 27. Sorry, so that's plus or minus 27. We know that 3 times 45 is also a factor, and then it's plus or minus 135. So those are all the possible rational zeros of this polynomial function. Okay, now what we're going to do is we're going to go ahead and graph this on Desmos to find the exact zeros of this function. So let's go ahead and plug this in. So we have x to the 5th minus 9x to the 4th plus 32x cubed minus 72x squared plus 135x minus 135. Okay, so let's take a look here. So what's happening here? Well, if you notice here, when you have this type of graph, and we're going to talk about this, this tells us that we have a multiplicity. Okay, this multiplicity, because of the graph and the way it looks and the way that it tells you, okay, when you have this type of graph, right, this is telling you that you have a multiplicity of 3, and that is a 0. So we can see that 3 is a 0. So let's determine that first. So we're going to check that. So if we know that 3 is a 0 of the function, let's determine that. So we're going to go ahead and plug in 3 for our synthetic division for k, and then we have 1, -9, 32, negative 72, 135, and then minus 135. So we're going to bring the 1 down. 3 times 1 is 3. Negative 9 plus 3 is negative 6. 3 times negative 6 is negative 18. 32 minus 18 is positive 14. 3 times 14 is 42. Negative 72 plus 42 is negative 30. 3 times negative 30 is negative 90. We get 135 minus 90 is positive 45. And 3 times 45 gives us positive 135. So therefore we get a remainder of 0. So therefore we can see that 3 is a factor, or a 0, excuse me. So 3 is a 0, and therefore x minus 3 is a factor. Okay, so now in step number 3, we're going to go ahead and write this out in factored form. We have x minus 3. Since we know this is x to the 5th, this becomes 1x to the 4th minus 6x cubed plus 14x squared minus 30x plus 45. So now that becomes x to the 4th minus 6x cubed plus 14x squared minus 30x plus 45. Okay, so now what we want to do is we're now going to go ahead and now factor this. Okay, now again, we know that there's a multiplicity of 3, so 3 is another 0 of this factor here. So let's go ahead and do that. So for step number 4, okay, we know that 3 is a 0 of that factor. So we're going to write down the coefficient. So we have 1 minus 6, 14, negative 30, and then 45. We're going to bring down the 1. 3 times 1 is 3. Negative 6 plus 3 is negative 3. 3 times negative 3 is negative 9. 14 minus 9 is positive 5. 3 times 5 is 15. Negative 30 plus 15 is negative 15. 3 times negative 15 is negative 45, which gives us 0. So again here, now we know that, again, 3 is another 0. So therefore, x minus 3 is another factor. Okay, now we have x minus 3 times x minus 3. And remember, this is x to the 4th, so this becomes x to the 3rd minus 3x squared plus 5x minus 15. So we have x cubed minus 3x squared plus 5x minus 15. Okay, so now let's go to step number 7. So we're going to go to step number 7 here. So we know that, again, we know that there's a multiplicity of 3. So that means 3 is another 0 of this polynomial function here, which is that factor. So let's go ahead and write out the coefficients. 1, negative 3, 5, and then negative 15. So let's bring down the 1. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. 5 plus 0 is 5. 3 times 5 is positive 15, which gives us a remainder of 0. So what does that tell us? Well, that tells us again that 3 is another 0. So therefore, x minus 3 is also a factor. So now let's write this in factored form. We have x minus 3 times x minus 3 times x minus 3. So there's the multiplicity of 3. Now since this is x cubed, this becomes 1x squared plus 0x plus 5. So that means we have x squared plus 5. Okay, so now this is the completed factored form because we cannot factor x squared plus 5. So now in step 10, what we're going to do is we're going to find the zeros of this polynomial function. So we're going to set everything equal to 0. So we have x minus 3 equals 0, or x minus 3 equals 0, or x minus 3 equals 0, or x squared plus 5 equals 0. So we know that this is going to be x equals positive 3, and x equals 3, or x equals 3, or x equals 3. Over here, we're going to solve for x by subtracting 5 to both sides. We're going to take the square root. Remember, that's plus or minus the square root of both sides. So therefore, x is going to equal plus or minus I times the square root of 5. So therefore, here are the zeros of the complex zeros of the polynomial function. So we have 3, 3, 3, and then negative I times the square root of 5, and then positive I times the square root of 5. So let's go ahead and put that in. So we have 3, 3, 3, negative I times the square root of 5. Move over and put a comma, and then I times the square root of 5. Check your answer, and there is the result.